right, so first step is, since it's already in complex form, right, then we just need to switch it to trig form, correct? Okay, so let's do a little sidebar action here. My R value is going to be 12, right?
Yes.
If you haven't seen the pattern yet, then you still got to do the negative 6 squared plus negative 6 square roots of 3 quantity squared, and then take the square root of that, and that's 36 plus 108, which is 144, which is 12. Okay? But if you see that square root of 3 on one of them, okay, you just take this number, right, you take that number and you multiply it by 2. Okay?
So the negative 6 had a second one, that doesn't matter, it's just use negative.
As long as they're the same, as long as, you know what I mean? As long as these two numbers right here are the same and one of them's got a square root of 3 on it, just multiply it by 2 and that's your R. Okay? That's a pattern that you should have seen a while ago. Okay? So then we got to find theta. Theta is going to be the inverse tangent of the square root of 3, which is 60 degrees. Okay? And this is in quadrant 3, right? So that means that my actual theta is 240 degrees. Yes, Okay? So this really is x to the 4th equals 12 times the cosine of 240 degrees plus I times the sine of 240 degrees. Yes? But now I gotta solve for x, right? So I'm gonna 4th root both sides. So that's going to give me x equals 12 times the cosine of 240 degrees plus I times the sine of 240 degrees to the 1/4 power. Yes? Okay? So applying de Moivre then, de Moivre is going to say that this is 12 to the 1/4 power times the cosine of 1/4 times 240 plus I times the sine of 1/4 times 240. Yes, Okay. So that, giving me my first root, is going to be x, oops. Whoops, what the? There, now it's working. X here is going to equal 12 to the 1/4 power times the quantity, the cosine of 60 degrees plus I times the sine of 60 degrees. Right? But that's only one of them. Now I need to find the other 3. So I take 360 and I divide it by 4 because I'm taking the 4th root, and that is 90 degrees. So the other ones are 12 to the 1/4 power times the cosine of 150 degrees and 12 to the 1/4 power times the cosine of 240. And 12 to the 1/4 power times the cosine of 330 degrees. Yes, sir.
I accidentally did 1.86. Do you want us to leave it in exact? 12, okay. And that's
Cleaner.
it. Okay.
So unless you get like a nice whole number, you want to
Yes.
use it. Okay.
Yep. Yep. Sorry, forgot that. Okay. Ben, pick that up.
I think so, yeah.
Okay. Yep. Okay. And then if I were to add another 90 degrees, I would be at 420 degrees, right? Which really is just back to 60, and then back in.
So, is there ever a time where if you left like the 12 to the 1 power, if you left it like that, would that be wrong? Like when you mark that?
Only if it would come out to be a whole number,
So like what?
like 32 to the 1/5 power. That's 2. 16 to the 1/4 power.
So like, is it? But then it would always be 2 in front of it. Like if there was
Yep. Yeah, this number out in front is always going to be the same. Yep. Okay. Now, this next example is if you turn the next page, it's kind of like a note sheet in the packet. If you flip that page over, there's 4 problems at the bottom of the back side. Okay. So this next one is one of those. X to the 4th equals 16i. Okay? So please find me the 4 roots of that one. I won't say anything. You do you. So ours. Oh, that's right. I'm not supposed to say anything. Spot check, that should be your trig form of the original complex number. 16 is your R, okay? Because there's this 0 squared plus 16 squared. Take the square root of that is just 16, okay? And then because it's straight up 16 on the real complex axes, our theta is 90 degrees, okay? So then I take the 4th root.
Why do you only need one solution when you're like bringing it to the 4th power, but when you're taking the root, you need 4? Just because,
What do you mean?
like, what was the theorem we learned?
De Moivre?
Yeah, when we use that, like, you just get one solution. Like, this is like no spin off.
Because that was taking, so the original De Moivre was taking a complex number to a power. So like you were taking 3 cubed, right? So if I cube a number, that's only going to give me one number.
But if you go in reverse,
But if I'm solving x cubed equals 27, I need 3 answers there. Yeah. Okay. So this gives me x equals 16 times the cosine of 90 degrees plus I times the sine of 90 degrees, all to the 1/4 power. So applying De Moivre, that's going to be 16 to the 1/4 times the cosine of 1/4 times 90 plus I times the sine of 1/4 times 90. Oops, that should have just been a regular old parenthesis. So that gives me my first one is x equals 16 to the 1/4. That's 2. Okay? So then going back to your other one, your last question, Nina, then all of the other 3 that I have to find will all have a 2 out in front for their R value. Yep. Times the cosine of, what is that, 22.5 degrees? Yeah?
It's 4 on the outside.
No, 16 to the 1/4 is 2. Not 16 divided by 4.
Okay. You got it, put it in. Yeah.
16 raised to the 0.25 power.
Whatever. Okay, yeah.
Okay. Right. What you did, so you got to put it in parentheses,
Okay.
because what you did is you did 16 to the 1st power, then divided by 4.
That makes sense.
Yep. If you put it in parentheses, then it's 16 to the 1/4 power. Yep. Okay. So then 360 divided by 4 is 90. So I'm going to add 90 to these angles. So that's going to be 2 cosine of, what's that, 112.5? And then 2 cosine of 202.5.
0.5. Wait, yeah.
And then 292.5. Yep. Good. Let's do one more. Find me the 3rd roots of that. I believe that this one is also in that on that packet. The next one. Yeah.
You said if that root's just.
Alright, so this is really what I'm asking here is we're asking for the 3 roots of -2 plus 2i. So we're looking for that. Okay? So my R value here is going to be 2 times the square root of 2. Right? Okay? Because it's 2 squared plus 2 squared. Or it's -2 squared plus 2 squared, which is 4 plus 4, which is 8, which is 2 square roots of 2. My theta prime is the inverse tangent of 2 over 2, which is 45 degrees. But because I'm in quadrant 2, my actual theta is 135 degrees. Okay? So this really is 2 square roots of 2 times the cosine of 135 degrees plus I times the sine of 135 degrees. All of that to the 1/3 power. Okay? So that's going to be 2 square roots of 2 to the 1/3 power times the cosine of 1/3 times 135 plus I sine 1/3 135. So that is, my first root is 2 square roots of 2 to the 1/3 power. Now we're going to leave it like that because that just gets pretty nasty trying to figure out, having it, I don't want this, that's even uglier kind of a deal. Okay, so we'll just leave it like that. I mean, if we really, really, really wanted to get into the math, this is really so 2 to the times the square root of 2 is 2 to the 1st times 2 to the 1/2, or 2 to the 3/2 power. Right? Because I add those exponents. Okay? And then that taken to the 1/3 power is the square root of 2, if you wanted to. If you wanted to go there, you could. But I don't expect you to go break that down to that's actually just the square root of 2. Okay? Right? So I don't expect you to do that, but that technically is what it is. Okay? Times then the cosine of 45 degrees plus I times the sine of 45 degrees. Yes? Okay. Then I have to do 360 divided by 3 is 120. So my other two roots are cosine of 165 and $285. Oops. Guess we'll redo that whole 285. Yes'm? Okay. That's all I got for you from section 6.6. That leaves you a mod here to study for tomorrow's test. Tomorrow's test will be one page. It will look very, very similar to that last page of the packet. Okay? Right? Last page of the review packet. The review assignment. No, so it's going to look like that whole review assignment. Yes, so that whole sheet. Okay? Right? It will look very similar to that. Okay? It'll be different problems, but I believe that the review is a fairly good indication of, yep.